Hi everyone, I welcome you to this video. I want to discuss something in chemistry, a topic in chemistry called carbon and its compounds. Specifically, I want us to discuss Solvey process. Solvey process is an industrial process for the production of sodium carbonate, which is a compound that is widely used in the manufacture of other products like baking powder. It is used in paper pulp industries. Sodium carbonate is used in neutralizing acidity. Again, it is used in eliminating issues to do with corrosion. So this compound called sodium carbonate is very useful in our life. I want us to go to the steps that are involved in Solvey process. Just as I've given out definition, I want us now to rush the steps that are involved. Step number 1 is purification of brine. And okay, before we can go to steps, I want us just to highlight the raw materials that are involved in process, what we need so that we produce sodium carbonate. Number 1, we need sodium chloride. Sodium chloride, which is not readily available. So what we will do, we will find a way of producing sodium chloride, and the only way in which we can produce it is obtaining it from brine. Brine is sodium chloride, but it has some impurities like like magnesium and calcium ions. Another raw material is carbon 4 oxide, which is also called carbon dioxide. This carbon 4 oxide is also not readily available. What do we do then to produce it? We decompose limestone, the calcium carbonate, or we can also roast coke to produce carbon 4. But for this, our case, I would like us to use limestone. We are going to decompose limestone for the production of carbon 4 oxide. Then water is also needed. That is number 3. Then number 4, we need ammonia gas. Ammonia gas is not readily available. So what do? We need to produce ammonia gas in a process called Haber process. Step number 1. Steps number 1. Purification of brine, sodium chloride, and addition of ammonia gas. Just like I've said, purification here, what we need to do, just I've said that brine is sodium chloride with impurities. We need to eliminate these impurities because we don't need them. So impurity number 1 is calcium ions. Number 2 is magnesium ion. We have 2 methods of eliminating these impurities. Method number 1, we can do precipitation. We can do precipitation of calcium and magnesium ions by reacting it with sodium carbonate or sodium hydroxide solution. Let's see what is going to happen. When we have calcium ions, then we react it with sodium. We react it with sodium carbonate. We react it with sodium carbonate. We are interested in carbonate ions. So we are going to form calcium carbonate solid plus sodium ions. So already you can see this one is a solid. So it is eliminated. Brine is just a solution. So when we have a solid, we can do filtration so that we can remain with this solid as a residue, and these sodium ions will get attracted to the side, to the filtrate, which is a solution of sodium chloride. Another way in which we can now eliminate magnesium is by reacting magnesium ions with sodium hydroxide ions. Sodium hydroxide ions. This is what is going to happen. We are going to have sodium hydroxide solid. Sodium hydroxide solid. With this, I think the equation is very balanced. With this, we shall have removed calcium and magnesium ions. Another method, method 2, is we can do what is called fractional crystallization. This is where now the contaminant which is calcium and magnesium ions are going to form what we call crystals, and we are going to be left with sodium chloride as filtrate when this one forms crystals. So when we are done with purification, as you can see, we will be left with pure sodium chloride solution. Then we add ammonia to that. When we add ammonia, we are going to form what is called ammoniated brine. Sodium chloride pure plus ammonia, we are going to get ammoniated brine. Ammoniated brine is just it just consists of water, ammonia, and sodium chloride solution. With this, we shall have been done with step 1. So we are going to move to step 2. Step 2 is the production of sodium hydrogen carbonate. Step 2. Production of sodium hydrogen carbonate. What happens here is this. As you can see, we have already have ammoniated brine. This ammoniated brine, we are going to introduce it to the Solvey tower, or we commonly sometimes we call it carbonator. At the carbonator is where limestone is. Limestone which we heat or we decompose limestone to get carbon 4, which we need in this process. So when we introduce this ammoniated brine to carbonator, this is what is going to happen. The limestone, calcium carbonate, when subjected to heat, we are going to produce calcium oxide plus CO2. When we produce this CO2, we are interested in CO2. What happens is this. Just as I said, water is contained in ammoniated brine. Water is going to react with this CO2. When water reacts with CO2, we form weak carbonic acid. Weak carbonic acid. This an acid. This an acid. When we form this acid, and just as I said, this ammoniated brine consists of water, ammonia, and sodium chloride. This carbonic acid, weak carbonic acid, is going to react with ammonia, which is a weak base. Let's see what is going to happen. So when this happens, we are going to produce, when weak carbonic acid react with ammonia gas, we are going to produce hydrogen carbonate ions. we are going to produce hydrogen carbonate ions and ammonium ions. When we have this, hydrogen carbonate ions is going to react with sodium in the brine, in this ammoniated brine. So this one is going to react with sodium to produce sodium hydrogen carbonate, aqueous, to produce sodium hydrogen carbonate, which is an insoluble salt. And this ammonium ions is going to react with chloride ions in the brine to form ammonium chloride. Ammonium chloride, which is aqueous. So already we have ammonium chloride and sodium hydrogen carbonate. What do we do? But it is combined. We cool it to 0 degrees Celsius so that we can form sodium hydrogen carbonate as crystals and ammonium chloride as filtrates. With this, we are done with step number 2. We are going to step number 3. Step number 3 is where now we do what we call the formation of sodium carbonate. Sodium carbonate. How are we going to form sodium carbonate? We are going to do filtration because sodium hydrogen carbonate and ammonium chloride are combined. We do filtration, we get our sodium hydrogen carbonate as residue. Then we do what we call thermal decomposition. Sodium hydrogen carbonate subjected to heat, we are going to produce sodium carbonate plus CO2 plus water. When we do this, we already have sodium carbonate, CO2 plus water. So you can see the CO2 is already recycled, and this one is very important and very useful since production of CO2 is very expensive. So when we can do recycling, it is very economical in this process, and that is one of the advantages of Solvey process. So when we have our sodium carbonate, we have it here. So now that ammonia is very expensive, we need also to recycle ammonia. So step number 4 is how to recover ammonia. Recovery of ammonia. What happens here is this. As you can see, in this, where did we, when we subjected heat to limestone, we were producing calcium oxide, which is a quicklime. This calcium oxide is going to react with water plus water, calcium oxide plus water, to form calcium hydroxide, slake lime. We are going to form calcium hydroxide, slake lime. When we form this calcium hydroxide, the calcium hydroxide is going to react with this ammonium chloride that we were left with as a filtrate. So when we react ammonium chloride with calcium hydroxide, we are going to produce calcium chloride plus water plus ammonia gas. Then you confirm if the equation is balanced. As you can see, we have chloride. Here we have two chlorines. Here we have one. The equation is not balanced. Hydrogen, we have here 2 plus 3, that is 5. Here we have 6. So you need to balance this equation. After balancing equation, now you can see we have calcium chloride, and this calcium chloride is the byproduct in this process. It is the only waste product in this process. You can see now we have recovered ammonia. We again take this ammonia to the process, and the process continues. And when, for example, this is an advantage. As you can see, the Solvey process is environmental friendly. It is pollution free. It doesn't pollute environment, because this is the only waste that we produce, which is also useful. Other raw materials are recycled. And for that, I think you have understood what I've explained there. Thank you for watching this video. You can subscribe, like, comment, so that when we do a video like this next time, the YouTube will automatically update you. Thank you so much for your time.